Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself before. My name is Irsyad Izzuddin. You can call me Irsyad, just like my friends call me like that. I'm now studying at University of Surabaya, State University of Surabaya, at Mathematics Education 23A class. With my student number, last three-digit student number is 024. Now, in this video, I want to explain my midterm exam answer in order to remedial midterm exam. Okay, so let's just go deep into the answer. So here's the PPT. Okay, we go to the first question. Question like this, story. So this question is basically just a story question that has we want to solve, and man named Irsyad runs a pastry business. In a week, he has a stock of 100 kilogram with flour and 40 kilogram of butter. To produce 1 can of nastar cookies, 4 kilogram of wheat flour and 1 kilogram of butter are needed. Meanwhile, to produce 1 can of castangle cookie, 6 kilogram of wheat flour and 4 kilogram of butter are needed. Now determine the maximum profit that Irsyad can get if each can of nastar cookies give a profit of 40 rupiah, 40,000 rupiah, and each can of castangle cookie give a profit of 20,000 rupiah. So the question is, please create a mathematical model from this question, and the second is find the profit using the graphic method. Now I have like this. Firstly, we model first. Suppose the X is the number can of nastar cookies that produced by Irsyad, and Y is the number can of castangle cookies produced by Irsyad. So the objective function, since we are search for the profit, so, and the profit from castangle cookies is 20,000, and from nastar cookies we have the profit is 40,000. So we will have the objective like this. So Z max is equal to 40,000 times X plus 20,000 times Y. And the constraint itself is contains from wheat flour and butter, since the wheat flour and butter supply is not maximum like that. It's we call terbatas. For the first constraint is for X plus 6Y less than 120, and for the second constraint is X plus 4Y less than 40. And after we bought all that, we need to find the solution. Now, firstly, we need to know, because we want to solve it with find the profit using the graphic method. Firstly, we need to graph the constant function. And to do that, we need to find the point where the line will go through. So we need to substitute 0, 0, 0, x0 and y0 to the equation. So we will get the point like this and like this. So we have the equation 1 will go through point 0, point 0, point 20, and point 330, point 0. And the line 2 will go through like this point. And then we have to sketch the graph, but I'll skip this before we go to that. And just to be cautious, I'm following the white sector, so this graph will be not dirty like that. So the next step after we sketch the graph is determining the feasible region. We can substitute 0, 0.0 to the equation 1, and it results 0 less than 120, and it is true. So because I follow the white sector, I will shade the other side, then 0, 0.0. So the feasible region will not be 30. And by substitute 0.0 to equation 2, it also results 0 less than 40. And it is true, and we do the same, like the equation 1. So the graph will be like this. Now, this is the equation 1, this is the equation 2. We have the shade. This is not a shade, but I use arrow to make it more clean, not dirty. Now, I use the arrow to shade the other side, then 0, 0.0. So this is the feasible region we will get. Now, you see this is a point A. This is a point C that we get. Point A is 0.10 and point C is 30.0. And there is, in feasible region, there is a intersection between two equation. I call this with point B. And how we get the point is to eliminate the equation 1 and 2. Then we will get the y or the x value, and we substitute the value to the equation, and we'll get the other one like that. And then after we graph this and we determine the feasible region, we have the feasible solution. Point A, B, and C is the feasible solution of this. Now, after we find the feasible solution, now we will search for the optimum solution. I'm sorry. Now, this optimum solution. By how do we do that? Now, remember that we have the objective function is z is equal to 40,000 times x plus 20,000 times y. We substitute each point into that z, and we get the value of z will be like this. And from this, we know that point C is the most high from other point. So C, that is 30.0, is the optimum solution. So the conclusion is this is case is a maximization case with one solution, which is z max is equal to 1 million 200,000, with x and y is 30 and 0. So in order to reach maximum profit, Irsyad should produce 30 can of nastar cookies and 0 can of Castangle cookies. Just like that. So it's all for the question number 1. Now we get to the question number 2. In this question, we just need to solve a problem using simplex method. This question is not a story-based, just a serve and solve question. So this question is like this. Using the simplex method, determine the minimum value of G is equal to 30 x plus 5y plus 4z that satisfies the constraint like this. So what do we do is we need to make the canonical forms or standard forms, someone called like that. So to do that, we need firstly, if the equation is less than less than equal to something, then we just need to add a surplus here. This first. Nah. And for the equation 2, because the mark is more than or equal to, so we need to subtract with surplus, and we need to add a variable artificial here. So, and for mark equal to, we need to add artificial variable also. And since this problem is minimization, so the value of artificial variable is positive big M in here. And then after we make the canonical form, we just need to solve it using simplex method. So as we know, this is the initial table we can make. I'm using the table that use ZG minus CG, the most often used table by my friends in my class, and basically everyone using it in my class, so I use it too, and I think this is very easy to understand. So this table contain ZG, of course, the CG also, basis, coefficient, variables, solution, and ratio. And we need to do the simplex like as usual. After we find the ZG, we find the ZG minus CG. We then, because this is the minimization case, so we search for the value of very, very big positive ZG minus CG. So here the value. So in simplex method or big method simplex, M is a very big number. So uh, 9 times of M is a very big number, besides all the number in here you can see. So we choose this as a column kunci or K column. Then after we choose this, we now will search for the row K row. Now, to find the K row, we need the very small ratio, but not negative and not like this. So the ratio is we get from the solution over by the K column. So here 10 over 5 is 2, 8 over 0 is undetermined. So here is I use strip in here, and what is called 15 over 4 is 15 over 4. Now, so the smallest number in ratio is 2. So we so this row become the K row, and after that the intersection between K row and K column is become the K cell in this is Z. So this will make the basis from the K row will be replaced by the Z from the K column, like that. And we do the same thing as we call it is iteration until we find the table is optimum. And here the table is not still yet optimum. And here the table is already optimum, but since this is a minimization case and the value of zg minus cg is all uh, less than 0, here you can see, then the table is already optimum. But you may notice that there is zg minus cg in a column that there is the variable of the column that is not being a base variable, and the value of its g minus cg is 0. Look, in this basis variable is contained s1, z, and x, but there is s2, who is the value of zg minus cg is 0. So there is other solutions. So we need to choose this column as a k column and do the same thing iteration again, and we will get this iteration table 3. So from this, we now get a new table. This is the basis S1, Z, and S2. And we have the same value of G. It is G is equal to 15. Yeah, but with a different solution. We came for the first solution is Z equal to 2. Eh, that is that 2? Yes, 2. And X is equal to 7/5. But the second solution is X is equal to 0 and Y is equal to 0 and Z is equal to 15/4. But the G value is the minimum value of G is same, that is 15. So that's all for the question number 2. So now we go deep into the question number 3. Using the simplex method, this is the question is same probably with the question number 2, but just a different problem. And because I already do it or solve it, and the answer is also different too. Now we have to determine the minimum value of z, which is satisfies this constraint. And we need to do the canonical form just like before. We have this canonical form and we have this canonical form. Just same like before. Now we will use it. Now we will solve it using simplex method. This is the initial table. Here, because the case is minimization case, so we need to search for the highest value of the g minus cg. So we have this column, and then we have the ratio like this after we divide the solution by the k column. And from this ratio, we have the smallest number. This is this row. So this is the k row, just like before. And we do the iteration same as the k and again. Now just to iteration table. Okay. Now the table is already optimum since the value of all zg minus cg is less than 0, less than or equal to 0. Then the table is already optimum. But there is still a artificial variable in the base or being a basis that called or namely A2 here. And the value of A2 is non-zero. As you can see here, 104/7, I think, yes. So from what I have learned, so there is no solution for this case. So the conclusion is, thus we can conclude that this problem is minimization case with no solution, or The problem itself may called as unworthy problem atau masalah tak layak. So what I wrong before in midterm exam, I wrong in previous midterm exam. I wrong in the first place of to solve the question 2 and question 3. This is so basic. So I first in here make the canonical form. I don't know how to make the canonical form of equal sign. I don't know. But after maybe just 5 minutes after the class is over, then I already remember that, oh, if there is no basis variable in the equation, so we need to add artificial variable. I remember that after maybe 5 minutes after the class is over. And the basis variable and the variable that can be a basis is just select variable and artificial variable. And also you can use basis variable with maybe if there is a question that the variable is only in that equation, you can use it by you can use it being your basis. Now I remember that, but I forgot the previous word. So I want that. So I want to say sorry for my mistake I made here and I made in midterm exam. Everyone need a progress. So I think that's my progress. Thank you for watching. Thank you for listening my video. I'm sorry if my explanation is not as good as my friend or maybe Miss or Madam or Mom Affiati and Miss Mila. I'm very sorry and thank you for watching. See you next time. Lastly, wassalamualaikum warahmatullahi wabarakatuh.